Welcome to today's webinar brought to you by Actian and Influx Data. I'm Stephen Fagg, Director at Database Trends and Applications in Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled Enabling Technologies and Strategies for Time Series Analysis. Now I'm going to pass the event over to Lewis.
Thanks, Stephen, and thank you all, regardless of where you are today, whether it's morning here on the West Coast or afternoon on the East Coast, or perhaps you're actually joining from Europe or Asia and it's the evening for you. I have the privilege of being part of this webinar, and I will be talking again on enabling technologies and strategies for time series analysis. Now, I'm hoping that what I present to you today will be complementary to what Anais is going to present, because I'm going to try to lay out a big picture about time series data and the analysis of it, which should actually include the actual collection, the data processing, the data management, and the fact that time series data isn't a single stream of data, and it isn't necessarily even about the point at which you collect it. That is, once a time series has been collected, you should also be concerned about when you use it later, and that you therefore may want to preserve and look at that time in a wider scope. So before I begin, I feel compelled to say a word about my sponsor, that is the company that takes the time to pay me to have the privilege to be here. I'm from a small company called Actian. We have around over 300 employees, going towards 400, and we're part of a larger set of funds that are provided to us by HCL, who purchased 80% of us, and then the other part is owned by a private equity firm. We do over 100 million in revenue. We have 10,000 customers. The name of the company might not be familiar to you, but the products that we actually have are, if you've ever heard of Ingress or you've heard of Versant, Pervasive with something called P-SQL or Data Junction or Matrix, or I could go on and on, VectorWise. All of these products are now underneath the Actian brand, and we've been continuing to take all of these products and the code bases behind them and innovate on them, bringing them together increasingly as a platform, but also making sure that that platform is able to take advantage of the latest underlying hardware and software and cloud technologies and standards. So for example, all of our major products, whether it's the Avalanche Cloud Data Warehouse or it's the Ingress Transactional Database or Zen, which I will talk a little bit about, all of these products now run in containers. They run with Kubernetes management. They are configurable and set up for deployment using Helm. So just a case in point of how we're continuing to innovate with technology that's rock solid and has been developed, proven, and tested by thousands of customers over the years. So let me say just a few words about the key product that I want to talk about, which is the Zen Database. Again, like many of our other products, it has a very long history. In the case of Zen, the code base, which is all in C and C++, goes back to 1982. The year I went, the year I went into college. So it's a very long and stable code base. It started on 82, 86 CPUs running on something called Microsoft Disk Operating System. Sound familiar? Probably for anybody that's old enough to remember it. But of course, the whole point is that we continue to innovate on that code base. And whereas it's a fully compliant, ACID compliant SQL database, it is based on a key value store as the underlying technology for that database. And as a result, we're able to use both a NoSQL API with it and a SQL API with it, which is important, as we'll talk about in a minute. The reason that's important is that you can therefore look at running it for rapid data collection using the NoSQL btrieve API, which tens of thousands of developers over those 40 years have adopted, used in everything from kiosks to point-of-sale devices to embedding into largely all of the smaller financial applications at one time that were used in everything from auto parts shops to GameStop to you name it, right? So it's a very efficient, fast underlying KVS engine. It puts all of the data into a common data format, but it also has an SQL interface so that it does fully compliant ANSI standard SQL. The data is always stored and encrypted. I don't want to go into too much about the product, but as you can see, it's something that is standard and would be familiar. The beauty of having both the underlying KVS, the ability to use it in a traditional relational database with SQL, or to use it much more programmatically using a programmatic API for the data storage with something called B-tree, meaning the NoSQL access, enables us to handle a variety of data types. And the fact that we have taken this very simple code base and deployed it on so many different operating environments, allow it to be virtualized, and also allow it to run on both Intel and ARM in a modular fashion, such that the smallest version of this can be on a footprint of like 5 megabytes and still give you full client server. Full client, The latest version of this, which we just announced last month and we're releasing this month, actually has a few improvements that are worth noting. The first is that we've improved the SQL performance by up to 90%. Obviously, it depends on whether you're running the queries that are used to benchmark and tell us what percent increase we have. If it's indexed or non-indexed, if it's a read or a write, if it's a bulk instruction versus just a single row in a table. But to just put that into perspective of something concrete, the latest benchmarks that we had a third party run this year for us were against MySQL, and it's effectively 5x faster. And again, depending on the type of operation you're doing, the report we're going to release it this month so folks can see it, is about 5x faster. As I said before, this can run directly on an operating environment. It can run in a virtual machine. It can run in Docker containers. And as a result, because of the size of it, we got a request from Intel to be one of the first data management platforms that they use as part of their reference framework for multi-access edge computing support, which is really going to be important for taking all of the types of applications and databases and the community that develops that, where it currently resides in the cloud, in much more of the core cloud, and taking all of that cloud architecture, technology, and community, and moving it out to the edge, where you might have it in a virtual cloud. Perhaps you could even have it, in a private cloud that is sitting out in a base station controller, a mobile switching center for base station controllers, or out on a disconnected Costco ship, cargo container ship. So it's a really big advancement, and I think when you start looking at 5G, it's going to make a real difference for being able to use open standard types of tools that will end up being invariably applied for a lot of time series data. So speaking of time series data, the improvements we've made in the actual Zen platform even include in things like an SQL capability for doing timestamps to data, which is very important to have that embedded as something simple that's used by people that don't want to learn a new API or that are not involved directly with the collection of that time series data. I'll just briefly say that, again, the MySQL benchmark I referenced, that's here. We continue to do references against virtually every other type of database out there because our database is so flexible into what it's used for in terms of the types of data, the mode of operation of that, whether it's you're collecting data up front or you're going back in a transactional fashion or in a bulk fashion and querying that data. Oftentimes in the past, that's meant you use a different database, and then you do some sort of extract, transform, and load, or extract, load, transform to get to that data. Why not be able to do all of it from the same data management system? So today we're going to talk about time series. Sorry for that little bit of background, and I know it took a good few minutes, but I think it's important that you understand the types of technology that could be used to enable time series. And where is time series? Well, the fact of the matter is it's pretty much everywhere in the edge. And the thing about the edge is you can't think about it independently anymore. It's not as if there's a set of data out there at the edge that is all going to be moved back to the cloud. There is just too much of it. As you get more electronic sophistication out at the edge for everything from IoT to much more in the way of mobile apps, you're going to end up with the need to have that data processed at the edge. But in all cases, there is a level of processing that's also going to be done in tandem, and often in an integrated cyclic fashion from the cloud to the edge, back to the cloud, and so forth. And so that brings me to this really major point I want you to understand, and it really relates to time series, is that the old way of thinking about the edge, that the majority of data is going to move to the cloud, is just not the case anymore. I remember 7 years ago when I started going to IoT conferences, and obviously with IoT, it's clear that is the bulk of the time series data at the edge. That everyone was thinking all that data would flow up into the cloud, but increasingly that's not the way that people are thinking about it. And part of the reason is that there's so much more compute intelligence, there's so much data at the edge that because of latency, because of concerns around privacy of the data and security, you're not going to see all of that data necessarily going into the cloud. And the other reason is not all of that data is very useful, especially past the immediate time at which you're collecting that data. And so just from a standpoint of filtering that data and throwing away the data you don't want, rather than even storing it locally where it could be subject to malicious attacks, why not just process it right there on the spot? Even in processing that data, there could be several levels of processing the data. And the types of processing that are done in some cases may be of an AI nature, machine learning. You're going to hear a lot more of that hopefully from Anais in a few minutes. But the point is that a lot of the data will be processed at the edge. This might seem a little complex, but my point here is that if you look at it from left to right, meaning the left side is the very far end of the edge, the right side being all the way back into the space of the cloud, it doesn't break down into a simple, this is the edge, this is the cloud. The edge is actually its own cloud in some sense. That is, there's going to be a set of devices that at the very edge, there will still be processing, and some of the processing over time is increasingly looking to be more sophisticated. But that sophistication is still going to fit in a very small compute real estate, if you will. In other words, even if you have a 32-bit processor, you're probably capturing signals at a fairly low speed locally to that smaller IoT component at the edge of that grid. But all of that is time series data, and a lot of it will be processed and stored locally, discarded locally, etc. And probably you're not even going to use a database at all in those situations. But there will be local machine learning, and there will be some need to store the data. Probably it will be stored just locally in memory or in a file system. But as you move up into the sophistication of more devices, for example, let's say it's several devices in a smart car, not necessarily an autonomous vehicle, but a smart car. Well, each of those may have a much more sophisticated processor with much more memory, probably even running a embedded version of Linux, for example. And in those cases, in the past, that probably would have had just a file system. But now it will have a database, and a lot of that data collection will be processed locally at that point. That process data is still a series of time series data, which may then get processed in combination with other data. So in other words, I could have the camera signal, the LiDAR signal, if it's you know, an autonomous vehicle, multiple of those, along with other data feeds that are telling me the speed I'm going at, the pressure in the tires, et cetera, et cetera. All of those time series data sets would have been processed individually and then processed collectively by something more sophisticated, which is probably using ML. Well, in that case, clearly the database is being used for several different functions. The data management has to be capable of handling those different types of data and those functions. And of course, then you move up to the next stage of looking across multiple sets of combined data. That could be done at a gateway level. And then above that, that data across all those different combined sets could be looked at either, let's say it's a factory floor, then multiple assembly lines or multiple robots or whatever it may be that had each independently multiple devices. That is looked at perhaps even on premise for security purposes if it's a factory and they're trying to guard their IP. Or some of that could be moved up into the cloud, or vice versa. Oftentimes, you're going to find for time series data, there's another set of data that's moving in at a different rate because it's probably some data that's telling you status or control based on the status of what you're sending upstream to it, right? So the time series data, in a nutshell, I know that was a busy slide, so I thought it's useful to put this one here. It's telling you that essentially I've got to be concerned with analysis of the data both on-device, cross-device, at that cloud data center, and then also consider that with the advent of machine learning, a lot of what we're talking about of the machine learning being run unsupervised with the inference of what decisions you're making on that unsupervised data is being made on the device. That didn't just come out of a vacuum. Clearly, that there had to be a baseline pattern that was analyzed for you to figure out exactly what that algorithm is used for that unsupervised inference. Well, all of that requires a huge baseline of data. That data then has to be fed in outside of the scope of the actual operational program. And then that data and that tuned algorithm is then further tuned on a periodic basis if you're getting drift off of it, right? So the point being that the time series data follows a life cycle, not just of the time series data itself, but of the processing that's being done on over the full operational life cycle. So a lot of what we think about with machine learning, with the tools for it and so forth, are in the cloud. And my whole point here is that expect that with things like multi-access edge computing and with the ability to run the same data management platform, or at least have open standard ways of doing the data integration and transformations between each of the disparate types of databases at each stage of that platform. All of that capability is going to start moving to the edge, so that a lot of the time series data will be simply done on the edge. An example of that, of where we've worked with a customer that is doing something on the edge in time series that I thought was real interesting, is Tsubakimoto. And they are a large Japanese company that builds factory infrastructure for other manufacturers, particularly in Asia and, for example, in China. And they have embedded Zen, formerly pSQL, formerly btrieve, for the last 20 years into their systems. And every 3-4 years, they basically continue to update the speed at which these conveyor belts are moving. And they're measuring and looking at everything that's going along that conveyor belt. So oftentimes it could be 10,000 items per hour over a series of 20 different conveyor belts. All of that is being fed into the Zen database. So this is a time series data collection case study that has been going on for 20 years. And over the 20 years, they keep updating things, and every 3-4 years, they'll look at what we have and decide, oh, we should get rid of Zen, or at least test it against other things, and we always come out ahead. So these are my key takeaways. the time series data is going to be processed at multiple stages at the edge. You're going to have to process more of it at the edge. Why not have a single data management platform that can support the versatility necessary to deal with the time series, regardless of whether it's just simple event processing that you need to handle programmatically, or it's to deal with it in machine learning. Well, that's it. You can see more about Zen here at these websites. I'll turn it back over to Stephen. Thank you, Stephen.